right? That's like the worst, right? Yeah, that is the worst. I've only been sick that much once. Yes, this is not a good feeling, right? So these things are just like that, okay? They spew out of both ends, right? Like here and there, here and there, this and this. This is a clump of stuff. There's a clump of stuff. Yeah? That's kind of fun. Isn't that fun? Not the analogy, but the star. How about this one? I think this is the cat's eye. So this is this guy. This is this guy. This is that guy. Remember that that's three-dimensional. How they form, we'll talk about how they form when we talk about stellar evolution. But it's three-dimensional, so sometimes when you see something, the other equivalent piece of that is on the other side of it, so you can't see it, right? The hourglass one, I put this on the desktop of our computer, yeah? And I think this is like the coolest nebula, right? There's one of the stars. The other one maybe we can't see, okay? And it's orbiting like this. Basically, we think these are binary systems, right? And one of them is a white dwarf that's spewing stuff. The other one is perturbing the white dwarf, probably in unpredictable ways. You know, the more chaotic ones. This is an orderly one. This thing's just sort of going and spewing stuff off into space like that. I put it on our desktop of our computer. Shannon eventually said to me, she said, "Honey, can we take that strange eyeball thing off the desktop?" Right? And I said, "Yeah, okay." But it's back on the desktop of that computer. Now that it's in the music room as a MIDI sequencer, okay, the eyeball's back on. She has nothing to say about that either, because she doesn't use that computer anymore. Okay. And then we're just getting large scale. These are pretty sketchy, okay? But this is a survey. This is a survey of every dot here is a galaxy, right? And this is a long way away. This is like I'm guessing 5 billion light years or something like that. Pretty far away, right? So every dot is a galaxy. Why is there a missing chunk right here? That's where we can't see because there are other stars in the Milky Way blocking it, right? We can't see the universe because the Milky Way is blocking our view of it, right? Dang it, you know? Okay? It's kind of the bananas in the ear joke, right? You know? I can't see that stuff because there's stuff in the way. Here's the map, and this was a wonderful map that the National Geographic Society put in their I don't remember what it was, a long time ago, 2000, something like that, issue. So you can look at this. There are groups of galaxies. Groups are a few million light years wide, 3 to 6 conspicuous galaxies, a dozen or so smaller galaxies maybe. They're only, and people are confused by this, only a few times more dense than the universe. We mean the universe as a whole, right? The density of all this stuff divided by its volume is a few times more dense than the universe as a whole. Okay? Some of the small galaxies orbit the larger ones. Here's a picture of our local group, and it consists of the Milky Way and a few, the large and small Magellanic Clouds, which are tiny little elliptical galaxies orbiting us. Andromeda, and I showed you a picture of that. Andromeda has a couple galaxies orbiting it. And then we are in a majestic state orbiting the Andromeda galaxy, yes? Okay?
That's your mother.
It's your, this one, this group here is a rather compact group, right? And it was discovered by an astronomer named Hickson.
Number 87?
In 1987. I don't know.
Number 87.
Okay? And then this is the last thing that we can talk about that really there's any sense that a lot of people agree with us, right? And this is clusters of galaxies, right? And these things are, the Virgo cluster is hundreds to, or 10 to 20 times more dense than the universe. So the Virgo cluster is a very, very dense thing. And I'm going to sort of skip over this because this is all pretty conjectural. So putting it all together, here's our solar system. Our solar system is surrounded by stars. The stars are in the Milky Way galaxy. Yes? The Milky Way galaxy is in a local group with the Andromeda galaxy, and then it is very close to the Virgo supercluster. Yeah? Yeah? I'm going to skip out of here because I want to do part of the scale model of the solar system because it's definitely more peppy than this. Okay? I've got some terrestrial planets, and I've got...
Everybody, check.
I've got some terrestrial planets. I got Pluto, and Pluto right now is, according to Murray, definitely a planet. Okay? There we go. Let's put Pluto out here. We know its proper places there. And Mercury is very much like our own moon. And it's very close to the sun. And then there's Mercury, Venus, isn't it? Yeah. We are the third rock. Yeah. There we go. And look how small Mars is. Not enough gravity to really hang on to its atmosphere, yes? Yeah, there we go, right? Okay. Now we've got some giant ones.
Jupiter.
Now we got some giant ones. Check it out, baby. Some giant ones. All right. We have Jupiter. Oui, oui. Oui, oui, monsieur. So relative to our planet, we're not so big, yeah? Yeah, we're just a fraction of it, right? Then we've got Saturn. I know. Then we got Saturn, right? I believe so. So this is their size. This is their size relative to each other, not their orbits. We'll do their orbits in a little bit here. Now, what do we have left? We've got this guy, and this guy, and this guy. What are they? What's the other one?
Oh, that one little meteor.
No, we already got Saturn up there.
Meteor thing.
No, this is not the sun. Yeah, there's only 9, so this one's actually a large pizza. Okay. You know, I can see where there's confusion, right? Just sat upon.
That's funny.
All right. All right. On 9. All right. Now, quickly, you got to trot. Come out here. Quick. Come on, quick. Run. Trot. You'll be too slow. Run. Trot. Okay, the bell's going to ring on us. So, well, you can't write on your own walls, but I'm at school now. I can write on the walls. Look how big the sun is. Look at that. That's a big pizza pie. That feeds 117. No, I'm just kidding. I don't know. No, it feeds 352. All right. A little applause. We better get back in the room. We're going to get stranded out here. Okay. Is the relative size. I was going to have somebody cut that out of paper and have like a whole bunch of people carry it in on their shoulders, like a big wrestling mat, and roll it out in the room. But, you know, budget cuts and stuff like that. Bill Sizemore.
Time for class.
Murray just showed me planets. I love physics more than ever. Is that what you're saying? Now the funny thing is, it'll be interesting to watch that video, because what's it going to do when I walk out in the hall? Does the